Hey calculus students! So the previous video was the lecture notes for lesson 1, which was on limit notation and estimating limits from graphs and tables. And in this video, we're going to focus on examples. So you kind of learned everything about limits, but let's do some actual examples that could be something that you might see on a quiz or on your homework. Okay. So here's example 1. It says, let h be a function defined for all real numbers x. What is the best interpretation of the statement below? So when you see something like this, the best interpretation, kind of what that means is give a summary in words or rewrite in words. Okay, so this is in the limit notation, and we just need to write in words, what does this mean? So what this is saying, we're kind of translating this, is the limit as x approaches 5, and then this little minus sign there. That doesn't mean the limit as x approaches -5. That means the limit as x approaches 5 from the left of the function g. So we can say of g. And then the equal sign means is 3. The limit as x approaches 5 from the left of g is 3. Another word we could use is translate. So you could see any of these, so best interpretation, summary, rewrite, or translate. All of that means kind of take the notation and write it in English. The other way that we could write this means the same thing, is the limit of function g, or the limit of g, as x approaches, whoa, my hand slipped. Approaches 5 from the left is 3. So either of those work. They mean the same thing, it's just whichever you prefer. Okay, example 2. So here's looking at a graph. So we have this graph of function g, and then we need to find the following limits, paying careful attention to the notation. So the first one is the limit as x approaches 2 from the left of g. So the limit as x approaches 2, I'll just give 2 a little highlight. And then from the left means from numbers smaller, so we're going from this way. And I can see that from the left, the function is going to -1. So that equals -1. B, I don't want you to be tricked by it. So B is the limit as x approaches 2. So whenever we don't have like the minus or plus sign that indicate from the left or the right, that means we have to look from both sides. So we already looked at the limit from the left. Now if I look from the right, I see that the limit from the right is +1. So I'm not just going to say this equals -1 and +1. You can't really have two limits. Remember in the previous video we talked about how if the limits from the left and the right are not the same, then the limit does not exist. So this one is D and E. The limit does not exist because the left and right hand sides are different. Cool. The part C looks at the limit as x approaches 4, and that specifies from the right. You don't really need that because from the left and the right, they're the same. They're both going to 2. So the limit as x approaches from the right, approaches 4 from the right is 2. And then finally we have, oops, I think I did a typo on this. I'm 100% certain that I wanted to say 6 right here. So I'm going to change that to a 6. So D says the limit as x approaches 6 of g of x. So here's 6. And some of you really might be tempted to say that the limit as x approaches 6 is -3. Okay? And that's because you can see there's this closed circle at -3. Really all this means is that f of 6 equals 3. So the function value at x equals 6 is 3. But we're not asking about the function value, we're asking about the limit. And the limit is just what's happening when you get really close to 6. So as I'm getting close to 6 from the left, and as I'm getting really close to 6 from the right, I can see that the limit is getting close to -1. So the limit is equal to -1, while the function value, oops, I forgot my negative sign, while the function value equals -3. Another graph, and this one has kind of an interesting multiple choice setup that you could see on my quizzes and that you could see on the AP exam. So this is very similar to a question setup that the AP exam has. So given the graph below of function f, which of the following statements are true? So here are my statements. I need to decide which of those are true, and then I will make a selection from over here. So my final answer will be A, B, C, D, or E, but I've got to base it on which of these statements are true. Very common problem setup for the AP exam. So let's just go one by one. I see in part 1, it says the limit as x approaches 4 from the left is equal to the limit as x approaches 4 from the right. So here's 4. And I can see from the left the limit is 2, and from the right the limit is +4. So this is not true. This first one is not true. I'm just going to eliminate it. Then I can actually eliminate any of the ones that have 1 in it. Test strategy for the SAT and ACT as well. Cool. Part 2 says the limit as x approaches 2 of f of x does not exist. So there's at 2. It says the limit does not exist. So I need to think back and think about in which cases will the limit not exist. The limit does not exist when the limit from the left is not equal to the limit from the right. So let's look at the limits from either side. So the limit from the left is approaching +2 over here, and the limit from the right is also approaching +2. So that limit does exist. So that is false. So I can get rid of, actually, I think I have my answer. It should be B. I wouldn't know that unless I had been eliminating, so let's check that 3 is true. So the answer should be B, so let's check that that's true. So the limit as x approaches 2 from the left equals the limit as x approaches 4 from the left. So let's find those limits. I actually just found the limit as x approaches 2 from the left. We got that right here. It's equal to 2. And then the limit as x approaches 4 from the left is right here. That is also 2. So that is true, which just confirms for us that B is indeed the correct answer. Yay. Pressing the spacebar again. I'm sorry. If you heard that. If you didn't hear that, it's no big deal. Okay. So, final example is right here. It's an example with a table. The AP exam has lots of tables on it, and I feel like it's something that maybe in your other years of high school math you haven't seen very often, so I think it's good to start practicing right away with tables. So the table below gives values of the function f at selected values of x. Which of the following conclusions is supported by the data in the table? So this is the same type of problem as the last one. Here they call them conclusions instead of statements. It's just different vocabulary, but they mean the same thing. There are my conclusions, and here will be where my actual answer lies. Okay. So let's check them out. So the limit as x approaches 3 from the left equals 8,000. So I need to figure out where 3 would be on my graph. And I can kind of see that right here. That is where 3 would be. So between 2.999 and 3.000. That is where 3.0 would be. Okay, so I'm just going to add that x value. But it says as I go from the left, which would be from this way, the limit is 8,000. But I'm looking at my y value and it says it's negative 8,000. So this is not true. So I'll get rid of my answers that include 1 because that's not true. Okay, now let's look at the limit as x approaches 3 from the right, so that's this way. And I can see that as I approach 3 from the right, my function value is getting close to 8,000. So that one, I'm going to leave. This conclusion is supported. And no, it doesn't say like which one is true, because with tables, it's kind of hard to say like for certain what a limit is, but it is supported by the data in the graph, meaning that there's evidence that seems to make that true. So I'm going to say 2 is good. So I'm going to get rid of option B, because option B does not include 2. So it's either A, which just means just 2, or D, which is 2 and 3. So let's check option 3. Option 3 says the limit of f of x as x approaches 3 does not exist. So again, remember to not exist. That means the limit as x approaches 3 from the left of f of x cannot equal the limit as x approaches 3 from the right of f of x. So are the limits from the left and the right not equal? They're not. From the left, the limit looks like it's 8,000, negative 8,000, and from the right, the limit is positive 8,000. So the limit, they aren't equal. This one's negative 8,000 is not equal to positive 8,000. So this is true as well. So our answer is D. These are the types of problems you're going to see in your practice problems, and similar to what is going to be on your quiz as well. I made these problems and I made your quiz problems. So rewatch this video if you need extra support. Make sure to do the practice problems as well to best prepare for what could be on your